Imagine spending all day in a small, floral wallpaper-lined room staring at thousands of tiny black dots on glass photographic plates for hours on end, while all day the portraits of famous astronomers, all men, stare down at you. Your job is to make calculations about the positions, brightnesses, and spectrocolors of distant stars. Your pay is absolutely nothing. In 2017, it seems nearly unfathomable to make complex calculations without a computer. But in 1895, long before the rise of digital computers, human computers, mostly women, were tasked with tedious computations, and more often than not received neither the recognition nor compensation they deserved for their contributions. But this was exactly what Henrietta Swan Leavitt and a dozen other women did at the Harvard College Observatory at the turn of the 20th century. Henrietta Swan Leavitt, despite her brilliance, was initially unable to find professional employment in astronomy. For one, she and many other female scientists faced discrimination based on gender bias. Another restriction was the lack of educational opportunities for women. Although Leavitt was educated in the classics, world languages, and astronomy at the Society for the Collegiate Instruction of Women in Cambridge, which would later be integrated into Harvard University, the same could not be said for many other women with interests in science. Only in 1902, 7 years after she first began volunteering at the Harvard College Observatory, did Leavitt finally receive a salaried job. But even then, she was paid only 30 cents per hour, equivalent to little more than $8 per hour today. Neither in her lifetime nor after her death did Leavitt receive the recognition she deserved for her contributions to astronomy. In her landmark study, Leavitt studied variable stars called Cepheids in the Small Magellanic Cloud. By studying these pulsating stars, Leavitt determined a definite relationship between the period and apparent brightness of Cepheid variables. Because the Cepheids she studied were all from the Small Magellanic Cloud, it was assumed that they were all close to each other compared to their distance from Earth. From this, she determined that a Cepheid in her sample of stars that appeared twice as bright as another Cepheid in the same sample was twice as intrinsically luminous. From this, Leavitt discovered that the longer the Cepheid's period, the more intrinsically luminous the star. However, Henrietta Swan Leavitt was not even able to claim her own discoveries. In line with custom at the time, the director of the Harvard College Observatory, Edward Pickering, signed for the 1912 paper Leavitt ultimately published, and gave credit to her only in the paper's opening paragraph, writing that the following statement regarding the periods of 25 variable stars in the Small Magellanic Cloud has been prepared by Miss Leavitt. Additionally, Leavitt never explicitly linked the period-luminosity relationship of Cepheid variables to the ability to measure astronomical distances in her paper. But this is not to say that she did not realize the implications of her findings. It is much more likely that she, because of her gender, felt pressure to refrain from making claims that male scientists had the privilege of making. However, Leavitt's work did not go unnoticed. In 1913, Einar Hertzsprung built upon Leavitt's findings about Cepheids' relative brightnesses, and was able to determine the variable's individual intrinsic luminosities. In 1917, Harlow Shapley was able to build a cosmic model of the Milky Way galaxy by using Cepheid variables at various locations within the Milky Way. One of the most prominent discoveries that relied on Leavitt's discovery came in 1924 when Edwin Hubble found Cepheids in the Andromeda Nebula and was able to determine that, because the Cepheids lay beyond the distance Shapley calculated as the extent of the Milky Way, the Andromeda Nebula existed beyond, not within the Milky Way galaxy. This was one of the first steps toward not only expanding our knowledge about the universe, but also expanding our knowledge of the size of the universe itself. Yet, during her lifetime, Henrietta Swan Leavitt received little more than an honorary membership in the American Association of Variable Star Observers. In 1925, Professor Mittag Leffler of the Swedish Academy of Science wrote to Leavitt to nominate her for the Nobel Prize. But Pickering wrote back, not only stating that she had died 3 years prior, but also suggesting that his interpretation of her work should receive the prize instead. Although Henrietta Swan Leavitt's portrait was never hung next to those scientists whose discoveries could not have been made without Leavitt's law, We know that it is because of Henrietta Swan Leavitt that, as our curiosity about the universe expands, so too does the universe itself.